Hey guys, this is Professor Janacek, and I'd like to go over a test for conservative vector fields. We will let F be the vector field FGH defined on a simply connected region, which we'll call D. We say that F is conservative on D if and only if the partial of the first component with respect to y is equal to the partial of the second component with respect to x. The partial of the first component with respect to z is equal to the partial of the third component with respect to x, and the partial of the second component with respect to z is equal to the partial of the third component with respect to y. Notice the connection, f taking the partial of f with respect to y, g with respect to x, f with z, h with x, g with z, h with y. So just make sure you understand that connection. Also, if our vector field f is just two components, f and g, then we really just have to look at one equality, the partial of f with respect to y and the partial with g with respect to x. Let's take a look at some examples. Let's determine if f equal to the vector valued function negative y comma x plus y. Let's see if this is conservative. Well, first, we will want to define our parts. Let's see, f, lowercase f that is the first component, negative y, and g is the second component, x plus y. Then, if we take a look at the partial of f with respect to y, we actually end up with negative 1. And the partial of g with respect to x, we actually get positive 1. Since the partial of f with respect to y is not equal to the partial of g with respect to x, then we'll say this vector field is not conservative. Let's take a look at another example. Let's let f be the vector valued function described by the first component is 2x cubed plus xy squared. The second component is 2y cubed plus x squared y. All right, so again, we only have the two components. We'll let the first component be called lowercase f, and the second component we'll call g. And now we simply want to take the first partial of f with respect to y. Notice I'm just looking at the first partial with respect to y. That first term, 2x cubed, doesn't have a y in it, so that becomes 0 when I differentiate with respect to y. The second term, however, becomes 2xy. And now let's take a look at the first partial of g with respect now to x. Again, the first component only has, the first term of this function only has y, so differentiating with respect to x, I get 0. The second term in g, if I take its derivative with respect to x, we get 2xy. Well, that's nice. Since the partial of f with respect to y is equal to the partial of g with respect to x, then we can say that this vector field is conservative. And there you go. Enjoy!